Today, we're going to see how we can replicate data between transactional databases and ClickHouse. And so I'm Arno. I work at Jump Trading for 9 years now. And so I've been in the database industry for 25 years. And today I'm also joined with Kanti. So Kanti, you can introduce yourself as well.
Hi, my name is Kanti. I've been a software engineer for a while, and I've been focusing on data engineering for the last few years. And at Alternity, I focus on replication tools for bringing in data from different sources into ClickHouse, and I'm a contributor for the Sync connector.
Thank you, Kanti. Today, we're going to introduce the topic, discuss the requirements of our project, the design choices, implementation details. Then there'll be a demo. It's a live demo. This is a live presentation. Don't hesitate to ask questions at the end as well. So, transactional database, what is it? So it's been there for 50 years. Everybody knows what it is. It's a textbook database. So it is row based. So it has table, rows, triggers, indices, and it's usually B-tree based. So that's the data structure. It speaks SQL, and it's usually ACID. So atomic, consistent, isolated, and durable. Like when you have sync, the data is persisted, and you typically store things like your bookings in airplane bookings, and it's based on transactions. And the most famous example in the open source is MySQL, followed by Postgres. And on the proprietary side, you have SQL Server and Oracle that are well known, has been there for a while. What is ClickHouse? So ClickHouse is the target of this replication, and so it's a fantastic database. If you don't know it, please try it. It's fantastic. So it's an open source columnar database. The data structure that it's based on is merge tree, and it has been created in 2009 by Alexei Milovidov at the Russian Google, Yandex. And it's specialized in real-time analytics. And you can know more about it if you follow this QR code. It goes to a very recent research paper on ClickHouse that shows that in details. And it's very popular. It has over 2,000 contributors. So that's why we want to replicate to it. What is replication itself? Replication is basically data synchronization between two systems, and it usually works between systems that are the same so that they can speak together, they understand each other. But today, I want to highlight that we are doing heterogeneous replication. So we have data in one system that changes, and it has to be written to the target system, but there needs to be some translation because they're not fully compatible. They're equivalent, but they're not fully compatible. And for that, we use logical replication. And we are fortunate to have log-based replication, which means that the changes are stored in a log, and we need to decode that log. And that process is known as change data capture, or CDC. Why is replication important? Of course, if you want to migrate one system to another, it's good to have replication because this way you don't touch the original system and the live data is present on system B, which can be same or different kind of system. And also, if you want to continuously synchronize, so for real-time analytics, you want to get insights on what's in your MySQL instance. Constar in Postgres or MySQL is slow for big tables, but if you synchronize it to ClickHouse, it's going to be instant, milliseconds. And so if you have a low latency replication, that's a solution. Also, you can replicate to different data centers in different locations. So it's good for fault tolerance and disaster recovery. So it's a very, very useful block, a building block when you design database systems. Why do we want to do this particularly to ClickHouse? We want to do some kind of HTAP, which is hybrid transactional analytical processing. There are proprietary solutions that are well known. I won't mention them here, but this gives you an open source solution to it. It achieves real-time analytics. And suppose that you're running out of space on your transactional system, like Postgres or MySQL. You have 100 terabyte in them. You need to purge the data. So you need some kind of data archival. And because you are transferring the changes, it's straightforward to have history table with all the changes that are in the binary log or in the transaction log. For our project, we wanted that replication to be lossless, so no data loss. I already mentioned low latency. We didn't want any duplicate. We wanted to be super simple, fault tolerant, and of course, open source. That's why we wrote it ourselves in order to offer it to the world. In terms of design choices, we like to keep things simple, stupid. So it's just one Docker container. We are trying to leverage what already exists. So of course, we're not reinventing the binary log, the transaction logs, or even Antler to pass the DDL, so the create table, etc., needs to be translated because they're slightly different. I'll show you an example in the next slides. And we didn't want to reinvent the wheel, so we leveraged Debezium, which is maintained by Red Hat, which is a very powerful change data capture library. In terms of design choice, it's very easy, one-to-one table mapping. We respect the primary key. We support all data types because we don't want to lose any data, any bit of data. In ClickHouse, we use replacing merge tree, which enforces, gives you some kind of uniqueness guarantee. If you run final, then the data is unique based on the primary key. And that's the same as Postgres or MySQL if they have a primary key. Also, what we wanted to have is that the same queries would run without any syntax modification between the two systems. And we'll show you a demo, so I'm going to show that later. Also, not all replication systems, especially heterogeneous, support full DDL. And so I'll show that you can add column, remove column, create tables, change the data types even. We found out that the time zone was also handled differently. So we have some compatibility between the time zone. And so we also wanted the replication state to be stored in ClickHouse. This way you can back up ClickHouse and basically restore it, and it will replicate from the state where you backed it up. So it's good for cloning. We wanted the same API as MySQL replication. Start, stop, and status. So show replicator status exists in this project. We want to retry on failure, of course, because we don't want to lose data. We have some replication filters. You can replicate only some tables. We have checksums. We have efficient dumpers and loaders. So you can dump and load up to hundreds of terabytes of data. And then replication will start from the point of the snapshot. In terms of architecture, as I said, very, very simple. What you see in the middle is the project. On the left, you have the source databases, and currently the target that we support is ClickHouse. In terms of implementation, one container, you use Docker Compose to start it. It's based on Debezium. It uses a multi-threaded applier, which makes it very faster, very fast compared to MySQL replication, which sometimes is single-threaded, and it's hard to really make it multi-threaded. So it's eventually consistent. That's by design. And we want it to be low latency. In terms of table conversion, you can see it's two different systems. On the left, I have MySQL. On the right, I have ClickHouse. And you can see that the system has automatically converted the data types into in32. Not null is removed because by default it's not null in ClickHouse. The nullable fields are detected. You have the primary key that is turned into an order by. The partition is detected and turned into a partition by. Also, you can see the helper columns, the version, and the is deleted, which keep track of the changes on the ClickHouse side. So the version is typically incremented when the same primary key comes back with a newer version. So updates typically. And when the row is deleted, we use the very convenient feature is deleted that is also baked in the replacing merge tree. You can see that here on the right. Okay, so it's time for the demo. So this is a live demo. So I started Docker Compose, and it is synchronized. So on the top, you have my demo, which is basically a bunch of SQL. In the middle, you have the sync connector, which has been started. So that's the Docker container. And then you have on the left MySQL and on the right ClickHouse. So let's start with selecting some data with the same query as advertised. Oh, so Martin is there. That's good. I have 23 rows. And let's try to make some changes to the data. So if I update and I promote everybody, as you can see, the job title changed from sales rep to senior sales rep. And if I select in ClickHouse, instantly the job title has been updated. I can do things like delete. So for example, here, if I select the three tables and count them, I have 122, 23. So same number of rows, that's expected. And if I delete, the delete happens. And if I rerun the same count, I'll have less rows. Remember, it was 23 for the last one, so it's 22. And if I run that in ClickHouse, I have 22 too, so it works. DDL, so if I add the hire date and select, so it's everybody is going to default to the current date. So I have added this field here, hire date. Does it appear in ClickHouse? That would be interesting. Yes, it does, because the alter table has been replicated, translated and replicated. I can also drop the column that I just added. So if I do that, okay, the hire date disappeared. And if I run the same thing in ClickHouse, the hire date disappeared. I can also run some inserts. So I'm going to add a new employee here. Okay, employee 2000 is there. If I run it in ClickHouse, employee 2000 is there. I can change some data types. Yeah, data types here. If I do a show create table, so this basically changes the office code to an integer. It was a string before, it's an integer. And if I run that, you can see that the office code is an integer. If I run the same query on ClickHouse, this show create table here, you're going to see that the office code is an integer. So sounds like my demo worked. So I will turn to Conti for another demonstration on Postgres. Take it away.
Perfect. All right. Thanks, Arno. So yeah, just like Arno did MySQL, I'm just going to walk through a quick demo for replicating data from Postgres. So we have the sync connector running on the top window, and then Postgres and ClickHouse on the bottom left and right. When you're replicating data, there's two parts. One is the initial snapshot, so we replicate whatever is on the Postgres database before the connector is started. So that part is called the snapshot, and then there's the real-time streaming, which pulls in data after the connector is started. So this example, we already have some data in Postgres. Log into Postgres, change into extended mode. Let's check the tables in the public schema. So we have two tables, TM and TM2. Let me switch over to ClickHouse. Check the tables. So yeah, so these two tables were replicated as part of the snapshot mode. So next step, I'm going to quickly show the data types and how it gets replicated from Postgres to ClickHouse. So yeah, so if you can see, in addition to the basic data types, we also have support for replicating much more complex data types like JSON-B, text arrays, and integer arrays. So on the ClickHouse side, a JSON-B gets mapped into a string, and array of strings, the items column and the prices column gets mapped into an array of int32s. So next up, let's try out a quick insert data. And so I just inserted a new row into the TM2 table. And as you can see in the logs, you'll actually see the complete insert statement. And then just another log says it was completely successfully inserted into ClickHouse. So let's go check the data in ClickHouse. Yeah, so you'll see there's no data loss. So this is, as Arno mentioned, this is something we've been focusing on a lot, making sure the data gets replicated exactly the way it is. So a lot of effort on precision and scale when it comes to decimal data types. But as you can see, yeah, so that the buying price, the selling price, and all the arrays are replicated successfully into ClickHouse. So one last step just to highlight the deletion functionality. So let's check what's in Postgres. We have 2 rows in the TM table. We should have the same in ClickHouse. So I'm going to quickly delete one of the rows with the UUID ending with 7.1. Okay, so then you'll see that in the sync connector logs, it performs an insert with the is deleted flag will be set to 1, and that should get reflected in ClickHouse right away. So yeah, so as you can see, the row with this UUID ending in 71 is now deleted. Yeah, that's it from me. Thank you.
Thank you, Kanti. So I wanted to show you another thing. Let me see if it works. So I wanted to run a checksum on the tables, that the employee tables, and you can see that the project comes with a checksum tool, and you can see that the hashes are compatible. So it means that we actually replicate it successfully. That's important to validate that the replication is working correctly. And so the demo is done. So if you want more information on the project, it's a GitHub project. So you have the URL, and also there's a Slack if you have questions. It's popular with MySQL users and ClickHouse users, and yeah, of course, ClickHouse users, and Postgres as well is popular.